go ahead and make a quick video for you guys tonight. This is a board somebody gave me from residential. I think this is out of like a Carrier Infinity unit. So it's an inverter power module. Just kind of exploring it here a little bit. So I've never worked on these Carrier units. I haven't been in residential for over a decade. So, but I could recognize what's going on here for the most part. So this actually has two inverter power modules. We've got one right here that drives the UVW for the compressor output. Got your single phase power coming in. A lot of times they have like a relay switches to power. Sometimes they'll charge it slowly through a current resistor or something on some units and then close the relay. I don't think they have to on this one because this one also has a power factor correction using the second IPM. So what they got is a single phase coming in, and kind of look, you got your little current sensors here. It's got the reactor. Not exactly sure if it's plugged in across here or how that is, but I could see on the inverter power module, this is the plus side. And over here, these three. You always do them in three separate ones. So in case you want to use separate current limiting resistors or whatnot to detect the current on each individual negative side output, just for measuring independent outputs on your compressor. Sometimes they'll just tie them all together, which you'll see over here. They are tied together, and they just have four resistors in parallel. They can read the voltage drop across this and things like that and do other wizardry. So, but anyway, they're doing something here to basically drive the reactor, which think of it as just like a buck type or even a buck boost, just depends on how it's configured. But it could regulate a steady DC voltage with a wide varying input. It also slows down the current, so you don't just get those really high current peaks at the top of the AC waveform, which is when your whatever charge your DC bus is at, as your AC sine wave comes up and down. There's zero current flow until your voltage in the sine wave crosses over the current charge state of the capacitor. Then you get current flow. And so what you wind up getting is a whole bunch of current flow, right at the top of the AC waveform, and then as it drops below here, you get none. So you have a very short period of the half, sine wave for the, each half cycle. You get a very small current blast right at the peak if you don't have any of this, current power factor correction, So if you just add a reactor just across the output of the rectifiers, the bridge rectifier to your capacitor bank, that'll slow down the current and give you some. I just put one on my little VFD on my 1AC unit outside, and it changed it a little bit. But this is actually used like active power factor correction, it looks like, using this other IPM module, just because it has the electronics, the semiconductors to do it, gate drivers, all that stuff. So that gets this charged up. And then over here you have your IPM inverter power module that drives the output. So you could kind of do some diode checks. You put this in diode checks, so you can read the voltage drop. And that's your basic check you always want to do. It doesn't matter if it's a VRF unit, a ductless mini split, or this from a high efficiency Carrier residential split system. If when these blow, they usually take out some components to where it's obviously bad. Sometimes it'll read good with this diode check and it's still bad, but most often you got to check something. So first thing you always do is kind of check your inputs, and you want to have your voltage drop normal from each diode going in, and then open the other way usually. So I notice that this is the negative and this is the positive, and like positive here, these are the same potential. I can get this out of the way and poke through the wax there. Yep. And this one's the negatives. I can call this on there steady. There we go. So we can kind of see that's going up. It's because the capacitors were charged from me doing it. So 0.49 volt drop, 0.49 volt drop. If we go the other way, I can get it from to here. I notice it's kind of like 0.36. And I think that's because we're reading through this IPM and stuff, so it's a little more to it than if it was just a bridge rectifier. So that just shows you that it isn't obviously toast, and you want to do both polarities both ways, because you want to make sure it's like really high resistance or almost open, the one polarity, and then got just a normal read across the normal diode drop the other way. So now we could do that over here. So if we go to each UVW, one way is going to be the normal voltage drop. So 0.4, 0.4, 0.4. And if I keep the same polarity and go over to the other side, here's the plus. See, it's just going up because I'm just reading to the capacitors right now. But it's not shorted and it's going to go real high. So and there it did. So now if I reverse the polarity, you do it again. This side should be really high now. Make sure I got a good connection. If I go over to positive, I'm going to read that same. You're reading through the diodes that are in the IGBTs or the MOSFETs. I'll show you why in a second. So right there. So that's not shorted, and you're reading the diodes in the drivers. So it's not obviously blown up. If, like I said, if these modules fry, blow up, pop, you won't get those readings usually. But you can have some other electronics bad, or even an input, whatever, popped or whatever, and it's still bad. But for the most part, at least you want to do a diode check just to, because if it's reads shorted or completely open, you know it's toast. So hold my tablet here because my phone's actually going dead and it was uploading to my other video for you guys. So here, this is kind of showing you your U, V, and W going to a compressor or a fan motor. Come on, focus, what the heck. And I know I used this before in a previous video, so I noticed I already still had this drawn up, so I'm just going to sequence between these. But here's your 6 drivers, and when I was doing this board over here, oops, I was showing in the other video, I was using 4 just to do a, kind of make a AC sine wave, not a 3-phase or a brushless DC type of output. So I can see this thing does not like focusing. Come on. Let's see if I can tap on the screen. Yeah, I'm pissing this thing off. Let me go back to 1. There we go. Sorry if that's too far, but anyway, as you, this is your plus up to 600 volts like it shows. So it's your plus and this is your minus. Just think your DC, your capacitors are plugged in here and here. So if you turn on, for the first step, you're going to turn on this IGBT, and it's going to pull this wire to plus. And then it's going to pull, you can turn on this IGBT to pull down this wire to negative. So you're applying, like, say, 480 volt unit, it's going to be about 600 volts being applied. It's going across 2 windings in series, though. So you see without that little highlight I put on there, it's kind of like a Y. It's wired like a Y, just like with an AC 3-phase Y, you're going to pull through 2 windings in series. And the third one's going to be no power. So you're going to pull through 2 with DC. And then you're going to, usually I was kind of saying, in my other video about maybe pulsing the positive side, but actually in here I see you wouldn't want to do that. It doesn't show all the detail here, but the way these things work is, since this is negative and your microprocessor and drivers are also all common and negative, it's real easy to drive these 3. These 3 kind of have a floating point. There's no negative because you're at the potential of the wires for the negative side, and you're putting a positive charge to charge up the capacitor on an IGBT or whatever, and that turns on the driver. So it doesn't show it here, but there's capacitors in on the drivers that get charged up from the other cycle, and then those have the electronics having wired, so there is a positive between these 2 points, between this point and a wire and this point and a wire and this point and a wire. So it's pretty cool. Not to go too deep with that, but so you'd want to probably do your pulse width modulation on the negative side and never on the positive. As I was thinking, I was looking at this, because the capacitor, you probably just drain that capacitor, right? That got charged up by trying to turn it on and off a bunch of cycles in a row. So you just want to turn them on once, and then the driver, once the IGBT is on, you have to pull the gate down to turn it off, which that driver chip does that. So pulse width modulation down here to get your average current or your varying current waveform if you're kind of doing like a 3-phase AC pattern. And there's various different tactics if you're doing just a DC brushless DC type. So there's your first step. So then for your next step, there's like 6 steps, right? It's going to keep this one pulled down to negative, and this one's now going to go up to positive. And it clocks the magnetic field so many degrees, depending on how many repeats there are in the motor for the windings. This is just a gross representation. So now we went from minus over there to minus on U now. So this one's pulled down, this one's still plus. And then you're going to move this one over. So now this one's plus, this one's still minus. And then now this one's going to be minus, and this one's still plus. And then, well, this one's still minus, this one's going to go to plus, and you have all your steps. And I think that's it. So this here, wish I would have made that bigger. This is kind of a, representation of the whole thing. Your microcontroller and your gate driver that does, this is like some of those chips that could do, like, drive 6 of these IGBTs on one chip. And some of those chips, like you get, they'll drive like 2, which is like what I have over here on this board. I already had this up here to hold my tablet, but so I have each one of these can drive 2 IGBTs or MOSFETs. Kind of works similar, and then this one does these 2. So what you do is, like, you're gonna want to have my drivers turned on over there. Kind of more or less doing it that way. Right, you're gonna, like I said, I'm gonna actually be pulsing the minus, not the plus, but I just put this up there for a representation, just for visual effects. But like, you would turn this one on and hold the low, the negative, down to this wire down to negative. Or actually, I'm sorry, they go the other way around. You're gonna tie this one. This one's going to plus, and this one's going negative, but you're going to pulse width modulate this one if you need to. And then when it reverses polarity, it reverses it by putting this wire now through this same driver, putting this one, so it makes plus voltage go to this pin, and then this one's going to be connected to minus, doing pulse width modulation. So you have your high and low of each one, and that's kind of why you have to have 4 pulse waveforms. And if you look at, like, the pulse width modulation, like on the chip data, you can kind of see what they kind of make sense there. So anyway, this is just a quick video. I'm gonna go too long on it, and I'm not using my phone, I'm just using my tablet. But just wanted to go through a little quick, just show and tell of just doing some basic inverter power module checks, just to see if it's if you just rule out that it's not definitely fried. Because if you do that diode check and it fails, well, it's definitely fried. It didn't fail, so who knows? This could be good. And a lot of people replace stuff, and it's like, could be the other board that was bad or whatever, or it could have been a leak in the system or whatever, but the unit got changed out, and then somebody handed me the board, so got a couple of these. So pretty cool. I might try putting power to them and kind of see if this runs without doing any data. I did look on some schematics and looked like there was some data going to the other board. So I don't know if this will take off just being powered up and charge up the capacitors or not. It'd be interesting if it did. It could be some nice clean power I could use for something. But anyway, not to go too long. Just another little quick video here. Now that I got my electronics laboratory kind of put back together somewhat again. Try to do some more stuff. I got a couple other things I want to mess with this week. Get some more videos out for you guys. Some more content, and just a lot of stuff's just memories for myself too. These videos, I'm going through my old videos all the time, just for stuff I worked on 15 years ago, since I started YouTube in 2008. So with that, catch you guys later. Don't forget to like, share, subscribe, and comment.